All right, so now what we're going to do is we're going to look at two-sided limits with piecewise functions. Now, I hope you remember doing one-sided limits with piecewise functions. I'm just going to do a quick review. Like if we were asked, we have our transition value. That's what I call it, the transition value. If we had a transition value here of -4, and I asked you, well, what is the limit of f of x as x is approaching -4 from the left side? We would go to the piece of the function where all the values are less than -4, right? And so x is less than or equal to -4, so we would use this piece. We would take the -4 and plug it into the left piece. But if it said, what is the limit of f of x as x approaches -4 from the right side, we would use the piece where the values are larger than -4. So this is the right side piece. Here's the left side piece. Here's the right side piece. Well, now we're being asked, what is the limit of f of x as x approaches -4, but it's a two-sided limit. We don't have the plus or the minus up here. So what we learned about two-sided limits a couple segments ago is very simply that in order for the limit to exist, the left side answer has to be equal to the right side answer. So if they're the same answer, then there is a limit, and that is the answer to the two-sided limit. But if the left-sided answer is different than the right-sided answer, then there is no limit because they are not meeting up at the same answer. Okay? And so, basically, to identify a two-sided limit when you're given a piecewise function, all you have to do really is plug your transition value into the left, get an answer, plug your transition value into the right, get an answer, and if it's the same answer, then the limit exists, the two-sided limit exists, and that is your answer. So what I'm going to do is I'm going to get a different colored marker here, and we're just simply going to plug in, okay? So to find the limit of this piecewise function as x approaches -4 from both sides, we want to find out what is the left side answer and what is the right side answer. So for the left side answer, we'll just plug -4 in here. -4 plus 5 is equal to 1. Now plug the -4 into the right side. -4 squared, now be careful here, the negative goes inside the parentheses, so -4 squared minus 15. -4 times -4, that's 16. 16 minus 15 is 1. And since the left side answer and the right side answer are the same, then that means that the limit does exist, and that is the answer. So the limit of f of x as x approaches -4 is 1. Okay, let's try a couple more examples. All right, so here's another one. I think a good idea would be for you to pause the video and see if you can write this one down in your notes, pause the video, and see if you can figure this one out on your own. Okay, so we have a piecewise function here. We have x less than 5, so the left side values are 4x minus 7. X greater than or equal to 5 is x squared minus 6x plus 2. That's the right side function. And we want to know what is the limit of g of x. What's the limit of g of x as x approaches 5? And because there's no superscript, this is a two-sided limit. As x approaches 5 from both sides, what is the limit of g of x? Okay, well, to answer this question, we're going to need to calculate the left side value limit and the right side limit as x is approaching 5. So as x approaches 5 from the left, all the numbers that are smaller than 5, we're going to take the 5 here and plug it into this piece. So we have 4 times 5 minus 7, and that's equal to, so 4 times 5, that's 20, and 20 minus 7, that's 13. Okay, so on the left side, the limit from the left of 5 is 13. Now let's do the limit on the right. We're going to plug 5 in here, and we're going to have 5 squared minus 6 times 5 plus 2. All right, 5 squared is 25. 6 times 5 is 30. 25 minus 30 is -5 plus 2 is -3. And so the left-sided limit is 13. The right-sided limit is -3. Not the same answer. And since they're not the same number, that means that there is no two-sided limit of g of x at x equals 5. And therefore, we are going to say no limit, or we could also put in DNE for does not exist. Okay? Let's do one more example. All right, let's look at this one. I think what you should do first is pause the video and write all of this out. I know it looks a little crazy and we have a lot going on in here, but I really want to squeeze out a lot of learning from this example. I can teach you a lot of things about calculus and about limits just from this example. So pause the video, write this down in your notes, and then we'll talk. Okay, so the first thing I want to say is this, is notice that we don't have any x's here, right? Instead, our input variable is t. Now that is very common in calculus. There will be a lot of problems that we do where instead of the input value being x, it's t. That's totally okay. You can have any variable, any letter. You can even use Greek letters. You can have any kind of letter as your input variable, okay? And your input variable will always be over here in a piecewise function. It'll be the thing that says, you know, that variable greater than or less than or something, a number. The next thing is this, is of course our output variable is v, okay? That's very common in physics and also in calculus when we're talking about the variable velocity, okay? So this is velocity is a function of t. T is usually time, okay? That's just sort of a little preview. Don't get too hung up on it. We're just dealing with the function v of t here. The next thing is this. Do you notice that neither one of these over here have an or equal to? This is when t is less than 7, and this is when t is greater than 7. No part of this piecewise function indicates what happens when t is equal to 7. That's important. We're going to talk about that in a minute, and it's going to affect the answer to this question right here. So here's our limit down here. It's a two-sided limit as t approaches 7 from both sides, right? So what is the limit of v of t as t approaches 7 from both sides? We expected to see this, but we didn't expect to see this. Mr. Ryan, what is that? Oh, well, you know, this is just one of those questions that you would have answered in an algebra class, right? It's what is v of 7? If you plug 7 in, what is the answer to the function? Just plug 7 in and get the answer. All right, well, that's the problem. The problem here is, oh, let's not mention that I gave you some crazy looking functions here. We have the square root of t minus 3 as one of the functions, and then a rational function t plus 5 over t minus 1. Let's not mention that at all. Yeah, I'm just trying to stretch you a little bit to show you that we can have any kind of function in here. They don't have to be polynomial, okay? All right, so here, this v of 7, well, normally with a piecewise function, to find out what the output of the function is when you plug a number in, you would have to plug that number into the correct piece. So we can either plug 7 into this one or we can plug 7 into this one. The problem is that 7 is not defined. And the reason I did this is because I wanted to teach you about something about piecewise functions, that sometimes there are certain values that are not defined in the function. Okay? And so there is no output value for 7. Because this is not defined at 7 and this is also not defined at 7, and the function itself is not defined in any way where t is equal to 7, the answer to this question is undefined, okay? This function is not defined for the value of 7, so we would just say that the output is undefined. There is no output value defined by this function for an input of 7, okay? All right, we're done with that. Now let's go to our regular limit problem. If you want to, now would be a great time. You can pause the video and you can do what you normally did in the last two questions for solving the two-sided limit. Okay, so now really all we have to do, just like we did in the other ones, is to find the two-sided limit. We just have to find the left side of 7, which will be here, and then the right side of 7, which is here. So here, left side of 7, all the values less than 7, that's here, that's this function. All the values larger than 7, that's this one here. So just plug 7 in here and then plug 7 in here. If it's the same number, that's your answer. If it's not the same number, then there's no limit. Very simple, okay? So I'll plug the 7 in here. We'll have 7 plus 5, okay, 7 plus 5 over 7 minus 1. 7 minus 1, okay. Well, 7 plus 5, that's 12, okay? And then 7 minus 1, well, that's 6, and 12 divided by 6, that's 2. So the answer to the top, the left-sided limit is 2. All right, the right-sided limit here, we're going to have the square root of, put a 7 in, minus 3. Well, 7 minus 3, that's 4. So we got the square root of 4. The square root of 4 is 2, and therefore the right-sided limit is 2. And since the left-sided limit is 2, and the right-sided limit is also 2, that means the limit does exist because it's the same number from both sides, and so the limit here is 2, okay? And that's it for piecewise functions, two-sided limits. We only have one thing left to do. We're now going to go through the grueling process. It's not that grueling. It's actually kind of easy once you practice it a bit, but it's a somewhat lengthy process for solving two-sided limits with an analytical function.